Okay, we want to talk about families of functions, and then we're going to talk about their transformations within a family. So first of all, we have some different families we could talk about. One, of course, family of functions would be linear functions. Okay, so they're anything that graph on a straight line. The most basic one, so the parent, what we call a parent function, is this most basic. And if you think about it, the most basic linear function you can think of is just f of x is equal to x. Okay? So the slope is 1 and the y-intercept is 0. And it's a very easy parent function to graph. It's going to go slope 1 right through the origin. So there's your first parent function for the family of linear functions. Okay? Then we can I'm going to draw a sketch down here. The second family we want to talk about is a quadratic function, or some people call it a square function, and you'll see why. It's anything in the most basic one, so the parent function, x squared. So f of x equal x squared is the parent function for this family of quadratics. Now, to graph this, I'll make a table of values. I have x, and then I have basically y is equal to x squared to figure out. And I'm just going to pick some values and figure out where they go. Minus 2, minus 1, 0, 1, and 2. So when x is negative 2, y is equal to 4. It becomes positive. When x is negative 1, I square that, and I get a plus 1. 0 for 0. When x is 1, I get 1. And when x is 2, I get 4. So there's a little bit of symmetry going on here. So I'm going to graph those points, 0, 0, 1, 1, 1, 4. And I'll do the same thing over here, 1, negative 1, sorry, that's negative 1, 1, and negative 2, 4. Let's connect the dots because this will be continuous, okay? Everything in between will also satisfy that solution, satisfy that equation, and be a solution. So that's what the parent function looks like. F of x, x squared. So there's two families of functions. One is a linear function and the other is quadratic. And you ask, okay, so if that's the parent function, what are some of the others? Well, some of the others would be just what we arrive at by going transformations. And transformations can be shifted up a little bit. So maybe I'll take the linear function and just move it up. Look at that. So now I've moved that up. So that's kind of related to the parent function is still linear. I could shift it down, okay, so that's also in the family of linear. Other shifts I could do is I could take this original parent and I can move it to the right. Okay, so if I move it to the right, then this point is now, say, over here, but it still looks like that. So that's a transformation, moving it to the right. Interesting enough, moving to the right looked a whole lot like moving everything down. They look very much alike because they are. Okay, there's other kinds of transformations we can do. We can vertically stretch these up and down. We can reflect them. We can do other things, and we'll talk about that. So let's go talk about our transformations. Okay, let's talk about the first transformation we'll talk about. Is called a vertical shift. Okay, and this is what happens when you start with a parent function, and in this case I'll pick x squared, but then we decide to shift it by adding a constant. So the new function that's shifted is the original, and then you add a constant to it, so plus some value. I'm going to say 4 in this case, okay? So if we made a table of values for this one, we'll start with x, and this one's going to be y is equal to x squared plus 4. Still I want to have some values over here, 0, 1, and 2. And let's calculate some of these. Square this negative 2 and get plus 4, and then another 4, get 8. Negative 1 squared is plus 1 plus 4 is 5. 0 squared is 0 plus 4 is 4. 1 squared plus 4 is 5. 2 squared plus 4, 8. Okay? So where my original graph was doing these points, 1, 2, 2, 3, 4, like that. Okay. My new graph, the g of x graph, the vertically shifted graph, is different. It's -2 and 8. Oh gosh, 1, 2, 3, 4, 5, 6, 7. It's right up here at the top. So I can just fit it. -1 and 5. 1, 2, 3, 4, 5. 0 and 4. 1, 2, 3, 4. 1 and 5. 2 and 8. It looks more like this. So it's interesting. The shape is exactly the same. It should be if I've drawn it very carefully. But what we've done is we've shifted the entire graph, just picked it up and moved it up 4 spaces. So that's a good description. If I asked you to describe the transformation, you could just say up 4 units, okay? And that would describe the transformation. I've already made a T-chart with values, so I don't have to label the points because I have this chart over here, but I might ask you to label points on a graph. In general, when you're looking at a vertical shift, okay, a vertical shift is in general, start with f of x and add or subtract a constant value, we'll call it k. So that's what you want to think about for a vertical shift. It's the original function plus or minus a constant. So for example, I'll let you try it on the next page actually. I want you to think about this one. We'll start with the parent function x squared, but then I'm going to start a new function g of x in the family, but it has x squared minus 3. So I think I would first ask you to describe this transformation. What do you think? Okay, good. Hopefully you said down 3, because of course we are subtracting 3 from every output, right? For what used to be y, the x squared, we now have minus 3. So we're going down. And I could graph it quite simply with this description. So you would start, maybe it's nice to start with the parent function drawn on here. So that's the f of x. The new graph, g of x, would just be down 3 units. So this, what used to be 0, 0, is now down 3 here. But it's basically the same shape. So I just drew that one down 3, same shape, but I made sure I took this point, took it down 3 points, and made the same shape. Now I might want to put some values on this. Remember, you could do a table of values. That's not hard. Or you could just remember the original parent was 0, 0. So if I took all the y values down by 3, so subtract 3, that becomes 0, -3 on the new one. What used to be 1, 1 on the original graph, subtracting 3 from y, I get 1, -2. What used to be 2, 4 on the parent, if you go back you can look it up and see what those values are in the parent. The value here would be subtracting 3, 2, 1 would be the new one here on the g of x. Okay? So you can label some points by just moving the graph down, label the points by subtracting 3 from the y. Alright, so that's a vertical transformation. I can go up or down. So plus a number moves you up, minus a number moves you down. So now that we have that, let's try a different transformation. Okay, horizontal transformations work a little bit different. It's very similar, but if you started with a parent function f of x is equal to x squared, if I want to change this left or right, I have to change the input, because remember, left or right is an x direction, and x are the input values. So I need to change the input values. So to do that, my new function would be inside what's the parent, and the parent is the squaring. So maybe I shouldn't have picked 2, let's pick 3. So I want to put the adding or subtracting a number inside the squaring, okay? So it's kind of like I've changed the input value a little bit, rather than before where I was changing output values. of the functions. So here I'm changing input values so I can go left or right. The thing is, because it's input now, everything's a little bit backwards, okay? So minus 3, if I describe that, is a right 3 units, okay? It's not in the negative direction, it's actually opposite that, and it's a right direction, okay? Which normally you would think it was positive, so it's a little bit backwards. There's an explanation you can ask me and we'll go over it. So let's see if we can graph this. We have a parent function, and I'll just put the basic values on here. I gotta see if I can connect those dots. Okay, that's my parent function. Now this one says shift it to the right 3 units, so I will do that. This point goes right 3 units, and I end up here. This point goes right 3 units, goes here. This one goes right 3 units, is right here. And the same with the other ones, blah, 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 but basically the shape is the same. And that's what the new graph would look like. I've shifted to the right 3 units. Let's try a different one. Let's say I had same parent function, f of x. I'm going to use h of x for yet another function. This time, I'm going to say plus 2, go ahead with my 2, and square it, okay? Okay, so the plus 2 is inside the function, okay, because then it's being squared. So it's inside. That means it's going to be a left or right, and because it's plus, that's left. Left, yeah, I can write, left 2 units, okay? So take your parent function and take everything to the left 2 units. So here, 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 and I've drawn g of x. A nice simple sort of sketch, okay? I've tried to do it fairly carefully, but I haven't labeled all my points. We'll save that. Alright, why don't you try one? Okay, I want you to go ahead and draw g of x is equal to x plus 4, and then it's squared. So the first thing you have to do is identify the parent function, okay? So and that would be an excellent question I could ask you, and you would say, oh, the parent function, f of x, is just x squared. That's your parent. My next question would be, describe the transformation from f of x to g of x. So describe the transformation, and you would use your words, and you would say left 4 units. Okay? Remember, plus left and right means left. So transformation left 4 units, and then I would ask you to draw it. So hopefully you should go take a second and you could draw it. I'll draw it right here. And it looks like that. I may or may not ask you to label points. This would be a sketch. Okay, let's just do a little recap and maybe a little kind of quiz here. If you saw, oops, here we go. You have an f of x, but then you added a number 4, and f of x could be any family of function, okay? Any function parent at all. How would you describe this transformation? And the answer would be up 4. Let's say you had a family of function, the parent, and then you said minus 2. What if you had a function that's modified inside, the input is modified? How would you describe that transformation? Be careful, it's not right, it's to the left 4 units. And how would you describe this one? Right 2 units. Okay, so that's a nice little recap, a little bit of what we've been doing. We're going to talk tomorrow a little more about some different kinds of transformations. We have a reflection to do and stretching. Okay, so this is a good start, and maybe we'll learn some different families as well. See you then.